As a globally significant winter sports hub, Oberhof hosts international competitions in biathlon, cross-country skiing, and ice track events every year. This entails substantial energy demands for operating the sports facilities, which not only incur high costs, but also result in significant CO2 emissions impacting our environment. In 2013, the city of Oberhof's entire energy potential was outlined in an integrated climate protection concept. This plan was developed by a working group consisting of IPH Seltzer engineers, ILK Dresden, and EA Systems. 3 years later, the Federal Ministry for the Environment, Nature Conservation, Building and Nuclear Safety published recommendations for the allocation of future funding under the theme Sporting Events as Drivers for Sustainable Development. The aim was to integrate sustainability more closely into sports and more tightly align environmental policies and sports. To achieve this goal for the 2023 Biathlon and Luge World Championships, the Thuringian Winter Sports Center Association commissioned the working group back in 2018 to develop a climate-neutral energy supply for all sports facilities in Oberhof. An analysis of the then current state revealed particularly high waste heat potential from the cooling systems of the winter sports centers. Several options were simulated dynamically and evaluated. The most ecological and economical solution was a combined cold and warm network. This innovative system, developed by our working group, is unique in Germany. The new cold network enables the use of waste heat from the ski hall and bobsled track. Using decentralized water-to-water heat pumps in areas such as the sports arena, multifunctional building, ski hall, and bobsled track, the waste heat is fed into the cold network. The heat pumps elevate the waste heat from a low temperature to a level sufficient to heat the buildings. If the waste heat is insufficient to maintain the cold network's temperature, the warm network can provide additional energy through a heat exchanger. The centerpiece of the warm network is the Bioenergy Center. This center combines a combined heat and power unit, or CHP, a heat storage system, a wood chip boiler using resources from Thuringian forests, a large heat pump, and a heat exchanger. The CHP and the wood chip boiler account for the majority of the heat supply. The second component of the energy concept is the area-wide electricity grid, a closed distribution network whose energy economic analysis was conducted by BBH Berlin on behalf of IPH. Previously, each sports facility had its own connection to the utility grid and was billed separately. The new concept integrates self-generated electricity from the CHP and photovoltaic systems installed at the sports venues. These systems were designed in collaboration with Max Solar Waltershausen. All connections are now bundled into a shared area grid, allowing the distribution of self-generated electricity among the sports facilities. A central stationary energy storage system stores surplus energy generated under optimal conditions and redistributes it, for example, at night. It also serves for peak shaving, reducing peak loads. This area grid significantly optimizes electricity costs. The energy concept is a remarkable engineering achievement. But is it worth the effort? Looking at heat generation, the answer is a resounding yes. From the calculated waste heat potential of 800 kilowatts, operating costs are reduced by nearly 93%. The primary energy demand decreases by 50%, and annual CO2 savings amount to 2,640 tons. The conclusion for electricity generation is equally positive. The annual consumption of approximately 4,000 megawatt-hours is more than 100% covered by the electricity generated from photovoltaics and the CHP. Within the working group, IPH Seltzer was responsible for overall project coordination. This included clarifying legal frameworks and potential subsidies, scheduling and financial planning, and preparing tenders. IPH Seltzer also managed the integration of innovative energy storage systems, upgrading the cooling systems for the ski hall and bobsled track, and analyzing the potential for PV systems at the sports facilities. With this energy concept, IPH Seltzer engineers demonstrate that energy-intensive sports facilities like those in Oberhof can be operated sustainably and efficiently, thus ensuring their long-term viability.